Hey y'all, I just want to go ahead and show you two ways on how to do a problem when you have a trinomial where your a value is greater than 1. So I look at this problem and I see that there's an a value greater than 1, right? 2 is greater than 1. And I can do factoring here. And there are two ways that you can factor this. One, the split method. Or two, we call it the swing method. The split method, to me, it makes a lot more sense, but the swing method sort of does. But the swing method is actually much faster. But, it's more power to you if you want to do it, either one. It doesn't really matter. So I'm going to go ahead and show you what the split method is. And basically, all I have to do is I need to check if there's a GCF. Always check if there's a GCF. We have a 2x squared plus 5x plus 2, and I don't see a greatest common factor that goes into any of those numbers there, so that means I can go ahead and proceed to my x method that I'm going to draw. And remember, a times c goes up top, b goes in the bottom. So what I'm going to do is I'm going to go ahead and multiply this 2 by this 2. And that's going to be my a times c. So I'm going to put a 4 over here. And then what goes on the bottom? Well, it's just going to be my 5. Oops. So I'll put a 5 here. Okay. Now, I'm going to go ahead and think of two numbers that multiply together that give me 4. And then using those two same numbers that add up and gives me 5. So I'm thinking 4 and 1. And I'm going to use the split method. So what's going to happen is I keep these, but I split the middle. You can agree that there's a 4x, and this is a 1x, and 4x plus 1x is going to give me 5x, and that's what I'm going to split it up. So I'm going to get 2x squared plus 4x plus 1x plus 2. And then since I have four terms, I can go ahead and just group. So I'm going to factor by grouping, and then I'm going to go ahead and find the GCF. So I put these parentheses here, and I'm going to go ahead and determine, okay, well, what is my GCF? My GCF is going to go here, and my GCF is going to go here. This GCF is referring to this term, and the GCF is I'm trying to find is for this group. So what number goes into 2x squared plus 4x at the same time? I'm thinking there's a, 2 here, and they both carry an x, so I put an x there, and I determine, okay, what's the lowest degree? The lowest degree is 1, so I can only just put, 1 here, or you don't have to put the 1 there. It makes no difference. So now I'm going to say, okay, well, 2x times what will give me 2x squared, and that's just x. And then 2x times what is going to give me positive 4x. That's just going to be positive 2. And then next, I need to figure out the GCF for this group, and I'm thinking, okay, the highest number, the greatest common factor that goes into 1x and 2 at the same time is just 1. So then I look at this, and I'm like, okay, well, 1 times what will give me 1x? Just x, right? And then 1 times what will give me 2? Just 2, right? So positive 2. And then I look at this again, I'm like, okay, got to find the greatest common factor again. What do I notice between this term and this term? Well, I see that they both carry an x plus 2, so I write x plus 2 here. And then I go ahead and write my parentheses again. X plus 2 times what will give me 2x times the quantity x plus 2. Well, I see that this is 2x times x plus 2, right? So it's just the same thing. X plus 2 times 2x is going to give you this. So I'm going to put 2x here. And I look at the other term, I'm like, okay, x plus 2 times what will give me this here? Well, this is the same thing as 1 times x plus 2, so I'm going to do the same thing. X plus 2 times positive 1 will give me this whole thing here. And then this means that this is factored, and this is what you call the split method. And it takes a lot more time, but it helps us understand why that works. But with the swing method, it's much faster, and I'm going to go ahead and write this problem again. So let me zoom out and rewrite this problem. And I'm going to use what we call the swing method. And I will tell you why it's called the swing method when I get there. So we're going to do the same thing. We're just going to go ahead and determine if there's a GCF. No, there's no GCF. And I'm going to go ahead and use my X here. I'm going to draw that X. And 4 is supposed to go up top, and 5 is supposed to go on the bottom. And we know that the factors here are 4 and 1. And now I'm going to go ahead, and I'm not going to split the middle or anything like that. I'm just going to go ahead and write X plus 4 times X plus 1. The 4 from here comes from there, and then this 1 comes from this 1, right? Now, we need to take into consideration that this is not our answer. This is not our answer, because we have a value where a is greater than 1. So what I'm going to do is I need to divide these factors by what I have here. So let's use a different color. I'm going to use green. And see this 2 here? I need to make sure that I divide both sides, but divide by factors by my 2. And if 2 goes into 4 perfectly, then I can go ahead and simplify that. So this is going to be x plus 4 divided by 2, which is 2. So I write x plus 2, and I'm done with that. And here, I have this x plus 1/2. 2 doesn't go into 1, so I'm just left with that. But this is where you swing it. Because the 2 doesn't go into 1, I can swing by just taking this 2 and moving it in front of the variable. So then I'm going to be left with 2x, where's that color that I use, plus 1, and this is my answer, because I was swinging this here, okay? And that is exactly what I have here, okay? And that is what I want to demonstrate today.